Hello everyone, welcome back to the channel. So in the last session, we have completed a bit small concept called colloids around us. So there we considered different points so that we can conclude about, say we are get surrounded by colloids. So we considered blue color of the sky, okay, formation of fog, mist, rain, and third thing we considered formation of river delta, okay, and even we considered food articles. Yes, so all by analyzing all those examples we said yes we are get surrounded by colloids. Now in this session we are going for a next concept or continuous part of the chapter, that is applications, or I can say applications of a colloids. Now if I consider applications of colloids, the first and foremost application includes electrical precipitation of a smoke. Say whenever if you consider the factories, say whenever if you consider the exhaust fans or exhausters, usually we call chimney, okay, chimneys present in the factories. Say whatever the exhaust gas, or you can say the gases which comes out of the chimneys, it contains smoke particles, okay. The whatever the gases in factories, in various factories, whatever the chimneys, whatever the gases out of the factory, these chimneys, they contain smoke. Yes, what is smoke actually? Yes, smoke is a colloidal solution. What is smoke? Smoke is a colloidal solution of solid particles. What are all present in the smoke? It contains charged particles like carbon, arsenic compounds, dust, etc. Please remember what is smoke? Yes, smoke is a colloidal solution of solid particles such as carbon, arsenic compounds, dust particles present in a air. Okay. Now, if these colloidal particles are exposed to atmosphere directly, what happens? They are charged one. They are going to damage. They are going to damage living cells. All type of living cells. It includes both animal as well as plant living cells. They are have a hazardous effect on a living organisms. To avoid that, what they will do, these are colloidal in nature, so whatever the charged particles like carbon, arsenic compounds, dust particles, they are they are charged particle. So what they thought of, we have to coagulate these colloidal particles so that it should not be allowed to mix with the atmospheric air or a gas. So how it is done? Yes, whatever the gases coming out of the chimneys, before passing out of the chimney, what they will do, that gas or gas that air is allowed to pass through a specially designed device. It is called Cottrell electrical precipitator. Cottrell electrical precipitator, or when it is called Cottrell smoke precipitator. Cottrell Cottrell smoke precipitator. Precipitator. So what is the use of this device or apparatus? Means yes, it has a two electrodes of a high potential difference of around how much? Around 30,000 volt. It has an inlet through which smoke is passed, and it has a outlet at the top. So what they will do, the smoke containing solid particles like carbon, arsenic compounds, dust particles, which is allowed to pass through the electrodes, allowed to pass through, or I can say pass between the electrodes of a high potential difference. How much is the potential difference applied here? Around 30,000 volt or more. See here, when that smoke is passed between the electrodes of high potential difference, what happens? All these charged particles or solid particles will be get coagulated or precipitated. Their charge will be removed. It leads to coagulation or precipitation. So whatever the gas which comes out of the outlet, this precipitator, which is free from those charged particles, or you can say carbon particles. It contains only the molecules but not any kind of charged particle, so that it is possible to remove the charged particles from a smoke with the help of a Cottrell electrical precipitator, or you can say Cottrell smoke precipitator. So it becomes one of the application of a colloids. So here, by knowing the colloid, it is possible to remove the charged particle. What is the concept here? Coagulation, or you can say precipitation of colloidal particles takes place. Okay, yes, this is one of the application, electrical precipitation of smoke. Well, so when smoke particles comes in contact with the oppositely charged plates, that is oppositely charged electrodes which are placed in a chimney, okay, they lose their charge and get precipitated. Okay, yes. Now coming to the next application, it is about purification of drinking water. So we know that the drinking water also contains a colloidal particles, that is clay particles, as a impurities. We call it is a suspended impurities. Colloidal particles present in drinking water in the form of a clay is considered as a suspended impurities. So how we can remove these suspended impurities means again by using a alum. So whenever alum is added to impure water, what happens? Coagulation of that impurity takes place. Once coagulated, so on filtration, what happens? That coagulated, okay, or I can say that precipitate can be removed, can be separated from water, so that water becomes pure. So it is, or I can say potable for drinking, or I can say water fit for drinking. Okay, so how we can done? By adding alum. Simply when alum is added to impure water, it leads to coagulation of a suspended impurities, that is colloidal particles. So it is also one of the application of a colloids, that is purification of drinking water. Okay. Yes. The third one, medicines. Say whatever the medicines we use, most of the medicines are colloidal in nature. Say examples includes, so these colloidal medicines are more effective because they have large surface area and therefore they are easily assimilated. And if I consider examples, say well-known example is Argyrol. Okay, Argyrol, a silver salt which is used in eye as a eye lotion. Say then next example includes colloidal antimony used in Kalazar. Okay, then milk of magnesia, okay, magnesium hydroxide, which is used to treat stomach disorders. We used to call acidity can be, okay, cured with the help of using milk of magnesia, magnesium hydroxide. Okay, yes. So you can consider even application of colloid means even in the field of medicine also, what most of the medicines we use, they are a colloidal in nature. Examples, please remember Argisol, colloidal antimony which is used in curing Kala-azar, and milk of magnesia which is used for stomach disorders. That is, okay, acidity. Next application includes in leather industry, that is tanning. So yes, what is tanning means? Here when a hide, that is animal hide, we used to call leather. So and when animal hide which has positively charged particles. So animal hide, the surface of animal hide which is going to carry positive charge. So we say which has positively charged the particles is soaked in tannin. Tannin is a chemical substance which contains negatively charged colloidal particles. Say animal hide has positively charged particles. Tannin, when hide is soaked in tannin, contains negatively charged colloidal particles. So one is positively charged, another is going to carry negatively charged particles. Now, because of this oppositely charged nature, one is positively charged, hide has positively charged particle, while tannin has negatively charged particle. Due to this opposite charge, what happens? Mutual coagulation takes place. Please remember, say in tanning, leather tanning we say, in tanning what will do? When hide containing positively charged particles, when soaked in tannin, it has negatively charged particles, it leads to mutual coagulation. It results into hardening of a leather. Say What is the use of this means? It leads to hardening of a leather. It gives the stiffness for a leather. So we say in even in tanning, in leather tanning, in leather industry also, we use the application of a colloids. Okay, yes, it becomes one of the application. Next one we already considered while dealing with, okay, cleaning action of soaps and detergents. Yes, while dealing with mechanism of missile formation, we considered cleaning action of soaps and detergents. They are also present in a colloidal nature. Okay. The next one comes to photographic plates and films. So here, how these photographic plates and films are generated means these photographic plates or films are prepared by coating. How those films are generated means are prepared means it is prepared by coating an emulsion of light sensitive silver bromide in a gelatin, or the glass plates are celluloid films. So how these photographic plates are prepared means, say an emulsion of light sensitive silver bromide in gelatin is placed over the surface of a glass plates or celluloid films. It leads to formation of a photographic plates. One of the application of a colloids. Okay. Yes, even rubber industry, well-known example is latex. Latex is a colloidal solution of rubber particle which is negatively charged, and coagulation of latex gives a rubber. Okay. Yes. Next one, if I consider various industrial products like paints, okay, ink, synthetic plastics, then rubber, graphite lubricants, okay, cements, etc. All are colloidal solutions itself. Okay. Yes. Now coming to the MCQ, here is the first one. Application of colloids in first one, electrical precipitation of smoke, purification of drinking water, medicine, all of the all of these. Yes, what is the answer? Yes, application of colloids is present. Yes, it is in the form of electrical precipitation also is right. Purification of drinking water also is correct. Medicine in the field of medicine also, which means what is the answer? All of these is correct. Okay. Yes. Well, with this, I'm going to conclude this chapter. Okay. Thank you.